Hello beloved students, in this lesson, we are going to deal with one of the lessons in a subject in the senior high school called Physical Science. Come on, join me! For today's lesson, we are going to talk about light as a wave, specifically on dispersion, scattering, interference, and diffraction. So our lesson objectives are the following. Number 1, define dispersion, scattering, interference, and diffraction. Number 2, discuss the difference of dispersion, scattering, interference, and diffraction. Number 3, perform an experiment on the interference and diffraction of light. And number 4, cite applications of dispersion, scattering, interference, and diffraction in real-life experiences. Before we proceed, let us have first our quick review. The previous module talks about transmission, reflection, and refraction of light. So when we say transmission, what comes to your mind? So in physics, light can refer to any electromagnetic wave, may it be gamma ray, radio wave, microwave, or the visible light. When light travels and strikes an object, a number of things can happen. Light may be absorbed, reflected, or transmitted. When light strikes a clear glass or a tinted glass, light is said to be transmitted because most of it can pass through that said object. With this being said, there are three kinds of materials. We have transparent, translucent, and opaque. Transparent materials are those objects which allow all light to pass through, such as clear glass, our windows, or a glass of water. Meanwhile, those translucent materials are said to allow some of the light to pass through it. Examples of such materials are our tinted glass, the tinted windows of cars, and our sunglasses. Lastly, opaque materials are those objects which does not allow light to be transmitted. Instead, light is absorbed in these objects. Materials such as wood, stone, metals, and concrete are opaque to visible light. Thus, light cannot be transmitted, but it is absorbed. Another thing that can happen to light striking an object is it being reflected. Reflection of light happens when a ray of light approaches a smooth, polished surface and the light ray bounces back. The incoming ray is called the incident ray, while the wave that is bounced away from the surface is called the reflected ray. When a straight line is drawn perpendicular to the surface, that particular line is called the normal line. The angle formed between the normal line and the incident ray is called the angle of incidence, while the angle formed between the normal line and the reflected ray is called the angle of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. So, if the angle of incidence is 45 degrees, therefore the angle of reflection is also 45 degrees. If the angle of reflection is 30 degrees, therefore the angle of incidence is also 30 degrees. The amount of light reflected by an object and how it is reflected is highly dependent upon the degree of smoothness or texture of the surface. When the surface is completely smooth, just like a plane mirror, it is said that virtually all of the light is reflected equally. This type of reflection is called specular reflection. However, in the real world, most objects have convoluted surfaces or rough surfaces. This results to the incident light being reflected in all directions. This particular reflection is called diffuse reflection. We can see our own image as we look at plane mirrors or even curved mirrors, which is an example of specular reflection. Diffuse reflection, on the other hand, does not allow us to see an image. In another instance, reflection can be annoying to people, just like when we are traveling or driving at night. Driving or traveling at night can be difficult on a wet roadway because of the annoying glare we get from the headlights of the oncoming cars. The glare that we get is a result of the specular reflection of the beam of light from an oncoming car. Normally, a dry asphalt roadway diffuses incident light. This instance would make traveling or driving at night on a dry road easier compared to driving on a wet road. Another thing that can happen to light is refraction. Refraction is the bending of a wave when it passes from one medium to another. The bending is caused due to the differences in the density between the two substances. The tendency of a ray of light to bend in one direction or another is dependent upon whether the light wave speeds up or slows down upon crossing the boundary. In the case of an electromagnetic wave, the speed of the wave depends upon the optical density of that material. The more optically dense a material is, the slower that a wave will move through the material. One indicator of the optical density of a material is the index of refraction value. Index of refraction values are numerical index values that are expressed relative to the speed of light in a vacuum. Now, how do we know the amount of bending? First, let us define incident ray, normal line, and the refracted ray. The ray that travels towards the boundary of two medium is called the incident ray, while the ray that has passed through the boundaries of two media is called the refracted ray. The normal line drawn perpendicular to the boundaries of two media is called the normal ray. The angle formed between the normal and the incident ray is called the angle of incidence. Meanwhile, the angle formed between the refracted ray and the normal line is called the angle of refraction. Now, if a ray of light passes across the boundary of a material in which it travels fast into a material in which it travels slower, then the light ray will bend towards the normal line. However, if a ray of light passes across the boundary from a material in which it travels slow into a material in which it travels faster, then the light ray will be refracted away from the normal line. One example of refraction is when a pen or pencil is placed in a glass with water. We can observe that the pen or pencil is somehow cut into two. This is because the refracted ray bends towards the normal line. Another example of refraction is when you are looking at an aquarium that is full of water. The aquarium has a glass over the top and the sides. If you stand back a little, you can see the same fish through the top of the tank and the wall of the tank. Because you see the light coming through the glass at two different points, you see two images of the same fish. The principle of refraction has many applications in optics and technology. A lens uses refraction to form an image of an object for various purposes such as for magnification. Refraction is also used in peepholes of house doors, cameras, movie projectors, and telescopes. Since we have been reviewed, let us now proceed with our activity. You will be given with words which are misspelled. You have to rearrange these letters to form a sensible word. Okay, so number 1, what word is that? Correct, that's diffraction. Number 2. That's right, interference. Number 3. Scattering, absolutely. Next, number 4. Dispersion. You got it all right. Good job. In the next activity, I will give the definition of the word and you are going to match the word to its correct definition. So what word is defined as a phenomenon in which two waves superpose to form a resultant wave of the lower, higher, or same amplitude? Next, what word is defined as the slight bending of light as it passes around an object? It is the spreading of white light into its full spectrum of wavelengths. It is defined as a phenomenon in which light rays get deviated from its straight path on striking an obstacle like dust, gas molecules, water vapor, and others. Are you done? Let's reveal the correct answers. Did you get it right? Good job! This time, we will do predict, observe, and explain. You will predict what will happen if I do something, then observe, then try to explain what you have observed. So for this activity, we are going to make use of an interactive simulation from PET. We will try to explore about interference and diffraction of light waves. These two objects at the left side are the light sources with the color green. So if I press one of these light sources, what do you think will happen? If I press one of these, I want you to observe what happens. Then, I want you to describe what is being formed after I press this particular button. What do you observe? What shapes are formed? What colors are produced? Now, I'll press the second one. Observe. Are there changes? What colors are produced? What patterns have been observed? Why do you think does this happen? Wave interference is a phenomenon that occurs when two waves meet while traveling along the same medium. So whenever the two light waves interferes constructively with each other, the two waves act to reinforce one another and produce a super light wave, which are the color green ones. On the other hand, whenever light destructively interferes, they destroy each other and produce no light wave or the dark bands. Now let us proceed with the diffraction of light. In the upper portion, the one with the red color is the source of light. In the middle is a sheet where a small hole is located. On the other sheet, in the rightmost corner, is the sheet where the light will be observed. What do you think will happen if I press this button to allow light to pass through the sheet with a small hole? Observe what happens. What pattern do you see? What shape can you see? What could be an explanation for this pattern? This time, let us try to change the diameter of the hole in the middle sheet. Do you think there will be a change in the pattern that we can observe? With our manipulation of the diameter of the hole, what do you notice to the patterns observed? So, diffraction is the slight bending of light as it passes around the edge of an object. The amount of bending depends on the relative size of the wavelength of light to the size of the opening. If the opening is much larger than the light's wavelength, the bending will be almost unnoticeable. However, if the two are closer in size or equal, the amount of bending is considerable and easily seen with the naked eye. Let us now proceed with our lesson proper. Remember that the electromagnetic spectrum could be gamma rays, X-rays, ultraviolet rays, infrared, visible light, microwaves, and radio waves. The visible light spectrum is the segment of the electromagnetic spectrum that the human eye can view. More simply, this range of wavelengths is called visible light. Other portions of the spectrum have wavelengths that are too large or too small and energetic for the biological limitations of our perception. Typically, our eye can detect wavelengths from 380 to 700 nanometers. The visible light is composed of the 7 colors: red, orange, yellow, green, blue, indigo, and violet. Violet has the shortest wavelength at around 380 nanometers, and red has the longest wavelength at around 700 nanometers. Visible light is a form of a transverse wave. A transverse wave is a wave in which particles of the medium move in a direction perpendicular to the direction that the wave moves. Transverse waves are always characterized by particle motion being perpendicular to the wave's motion. A transverse wave has the following characteristics: wavelength, crest, amplitude, trough, and origin. The line drawn through the center of the diagram represents the origin, the equilibrium, or the rest position of the wave. The crest of a wave is the point on the medium that exhibits the maximum amount of positive or upward displacement from the rest position. The trough, on the other hand, exhibits the maximum amount of negative or downward displacement from the rest position. The amplitude of a wave refers to the maximum amount of displacement of a particle on the medium from its rest position. Lastly, the wavelength of a wave is simply the length of one complete wave cycle. So, a wavelength can be measured as the distance from crest to crest or from trough to trough. Long ago in the science community, it was believed that light was composed of a stream of particles. However, it was a British erudite and physician called Thomas Young who convincingly demonstrated the wave nature of light through his double-slit experiment, known today as the Young's light interference experiment. When the waves emerging from two narrow slits are superimposed on a screen placed at some distance parallel to the line connecting these slits, a pattern of bright and dark fringes regularly spaced appears on the screen. This is what he calls as the interference pattern. This is the first clear proof that light added to light can produce darkness. This is what we have observed also in our interactive simulation that we have done a while ago. In order to observe interference in light waves, the following conditions must be met. First, the sources must be coherent. That is, they must maintain a constant phase with respect to each other. Second, the sources should be monochromatic, that is, of a single wavelength. Now, there are two types of interference. We have constructive and destructive interference. Constructive interference takes place when the crest of one wave falls on the crest of another wave such that the amplitude is maximum. These waves will have the same displacement and are in the same phase. In the opposite manner, destructive interference happens when the crest of one wave falls on the trough of another wave such that the amplitude is minimum. The displacement and phase of these waves are not the same. Then let's proceed with diffraction. Diffraction is the slight bending of light as it passes around the edge of an object. The amount of bending depends on the relative size of the wavelength of light to the size of the opening. If the opening is much larger than the light's wavelength, the bending will be most unnoticeable. However, if the two are closer in size or equal, the amount of bending is considerable and easily seen with the naked eye. In the visible light spectrum, red with the longest wavelength is diffracted the most, and violet with the shortest wavelength is diffracted the least. Because each color is diffracted a different amount, each color bends at a different angle. The result now is dispersion. Dispersion of light occurs when white light is separated into its different constituent colors: red, orange, yellow, green, blue, indigo, and violet, because of refraction. Visible light or white light can be split up to form a spectrum using a prism. A prism is a block of glass with a triangular cross-section. As visible light waves enter the glass, they are refracted because they are slowed down from the air as it enters the glass. The spectrum of colors is produced because different colors of light travel at different speeds in glass. Red light is slowed down the least by glass and is refracted the least. Violet light is slowed down the most by glass and is refracted the most. As a result, the colored light spreads out to form a spectrum of white light. So what then is scattering of light? When sunlight enters the atmosphere of the Earth, the atoms and molecules of different gases, dust particles, water vapor, in the air absorb the light. Then these atoms re-emit light in all directions. This process is known as the scattering of light. The intensity of the scattered light depends on the wavelength of the light and the size of the particles. Air molecules and other particles that scatter light are called scatterers. Scatterers don't scatter all the colors equally. Instead, they scatter the shorter wavelengths, violet, blue, and green, in greater amounts than the longer wavelengths, yellow, orange, and red. This type of scattering is called selective scattering, or also known as the Rayleigh scattering. This explains why we have a blue sky during the day and a reddish sky during sunset. Another type of scattering is the May scattering or the May effect. Cloud droplets with a diameter of 20 micrometers or so are large enough to scatter all visible wavelengths more or less equally. This means that almost all of the light which enters the clouds will be scattered. Because all wavelengths are scattered, clouds appear to be white. When clouds become very deep and heavy, less and less of the incoming solar radiation makes it through to the bottom of the cloud, which gives this cloud a darker appearance. Now that you have learned about these four terms, how are you going to differentiate them from each other? Now I want you to try to differentiate and describe these terms using your own words, using your own language, so I would know that you really have understood this lesson. After our discussion with interference, diffraction, dispersion, and scattering, let us now go over the different applications of these terms. First off is diffraction. Do you notice the different colors in a CD or DVD? We also have the shadow. These two pictures could be explained by the diffraction of light. Next is we have interference. What do you see? In the first picture, we can see that the soil has a liquid with different colors. Have you seen or experienced such event? If you have spilled to the land a certain oil or kerosene or gasoline, then probably you have seen such event. In the second picture, we can observe that there is a bubble of soap with different colors around it. Again, these two pictures can be explained by interference of light. Then we have dispersion of light. In the first picture, we can see a rainbow is formed in the sky, and in the second picture, white light enters a prism and it separates into different colors. Lastly, we have scattering of light. Mentioned earlier, we have the blue color of the sky, the white clouds, and we have the reddish sky during sunset. Let us now check your understanding of our topic today. This is known as pick a number. So once you pick a number, a question will be shown and you have to answer it. Let's begin. Pick a number from 1, 2, 3, 4, and 5. Have number 2. It is responsible for the alternating light and dark bands when light passes through 2 or more narrow slits. What is it? Then choose again another number. So, number 1. It is responsible for light spreading as it passes through a narrow slit. What is it? Next number. Okay, you chose number 3. It occurs when molecules are more capable of scattering a selected wavelength of light. What term is being described? Then choose again another number. Okay, number 5. The reddish sky during sunset as well as the blue sky can be explained by blank. Finally, we have number 4. It is responsible for the bending of white light into different spectrum of colors. What is it? Have you answered it all correctly? Congratulations! For your assignment, I want you to do performance task number 3. First, you have to take a selfie picture with one of the applications of any light phenomena. Second, write the correct explanation as to why such phenomenon occurs. Remember that during the discussion in this video lesson, I have just presented the different light phenomena, but I have not explained as to the detail why such phenomenon occurs. So that will be your task for the performance task number 3. Once you are done, you have to print your output in a bond paper for those students whose modality belongs to the modular printed. while for those who are under the modular digital, you may just send a soft copy of your output through my email or through my messenger. Submission of your performance task will be on or before June 18, 2021, that is 1 week from now. Here is how you will be scored with your performance task. First, correctness of explanation, that is worth 20 points. Quality of your selfie picture, that is 15 points. Creativity of your presentation, that is 10 points. And timeliness of submission will get you 5 points, a total of 50 points for this performance task. As we come to an end in this lesson, I will leave you with this particular quote by Douglas Payles. Sometimes it is important to work for that pot of gold, but other times it is essential to take time off and to make sure that your most important decision in the day simply consists of choosing which color to slide down on a rainbow. Thank you so much for watching. I hope you learned something today. Please don't forget to like, subscribe, and share this video so other students will also be informed. Stay tuned for more videos. Goodbye!